Good morning, everyone. Welcome to the fifth day of FDP session. Today we have our speaker, Dr. Bam Bahadur Sinha. Dr. Bam Bahadur Sinha obtained his PhD in MBA IT and Management from Nagaland Institute of Technology. He is an expert in recommender systems, machine learning, data analytics, artificial intelligence, and operating systems. He has 5 years of experience, served as teaching assistant in NIT Nagaland and ad hoc faculty at NIT Andhra Pradesh, India. He has published more than 10 research papers in journals and conferences, executed 2 projects titled Node B catching in 4G LTE networks and development of website for faculty and student interaction. To list few of his achievements, he obtained gold medal during his post-graduation. 3 times he is a GATE qualified person. So let me invite Dr. Bam Bahadur Sinha for the session. Welcome you, sir.
Good morning, one and all. Thank you for the introduction. So today we will be discussing about the recommender system. So I'll share my slide now. So we will also have a small hands-on session on the recommender system. We will see how the recommender system works from scratch. So we'll start with the introduction now. So is my screen visible?
Yes, sir.
Okay. So starting with the introduction of the recommender system. So we'll start with a famous quote by the Steve Jobs that a lot of times people don't know what they want until you show to them. That is the working principle of the recommender system. Until unless we are going to show to the user what they might be interested in, they are not going to purchase it, right? So one of the example I'll show means I'll discuss before coming into the formal definition of recommender system is like in around 1988, one British mountain climber named Joe Simpson, he wrote a book called Touching the Void, and it got very good reviews at that time, but only it received only a modest success and it was soon forgotten. Then a decade later, around 10 years later, a very strange thing happened. One another author named John, he wrote another book named Into Thin Air. So this book was also related to the mountain climbing only. So that, and it received very high demand by the public. Suddenly, what was observed that the previous book, Touching the Void, started to sell again. And the demand for the Touching the Void was so high that it even outsold Into Thin Air, that second book. So what exactly happened over here? So well, it turns out that since both the books were based on the same theme, that is the mountain climbing, the Amazon suggested that readers who liked Into Thin Air would also like Touching the Void. So when people took in the suggestions, they actually liked the book, and as a result wrote some positive reviews, which resulted in some more sales, ultimately leading to the recommendations. And thus it started kicking in a very much positive loop. And this is what I'm talking about. This is what the power of recommender system is. So coming to the formal definition of recommender system, and one more quote by this American novelist named Harper Lee. She quoted that many receive advice, only the wise profit from it. So in our day-to-day life, we all come across many advices, like from our supervisor or from any professional. We used to come across many advices. So it depends on us how we are going to use that very advice in an efficient way to make our life better. So this philosophy is followed by the recommender system also. They used to they used to check the user profiles, or they used to um, consult with other similar users in order to make the recommendations. That and all we will go into that in the upcoming slides. So the formal definition for this recommender system says that it it works in either two of the possible ways, either for making the predictions in the sense like making the prediction of the ratings, or the whether the user will be interested or not interested, or the other is the ranking base. So in order to rank any set of items, in what ranking the user might be interested in that item. And this recommender system is also referred to as the information filtering system. So whenever you come across the term information filtering system, you can break this into two words. One is your information and the other is your filtering system. The information, you all know that any useful data. The filtering system, what it does, when we have like continuous streamline of information over the internet, or and we want to trim or we want to discard the irrelevant information from that in order to save us from the information overload problem. In that case, the filtering system will come into the picture. That is what the role of information filtering system is. The same you can relate with the recommender system. When you talk about the e-commerce environment, we have around millions of products available online. But we all know that when we open a e-commerce website, like if you open amazon.com or if you open a Netflix, so only limited space is there on the window. So how efficiently to arrange the set of products so that even we can cover a lot more and more products, as well as the product should be very much convincing to the user. We should not show any irrelevant product to the user. For suppose example, if I open my Netflix account, and if you open the Netflix account, the recommendation of the movies will be completely different, because in my case they will check my interest, what kind of movies or what kind of TV series I am interested in, and in your case they will be checking your interest, what you might be interested in. So this is how they are going to retain more and more customers. There is a If we summarize this recommender system in terms of definition, it can be into two-fold benefit. The first is from the user perspective, and the second is from the vendor's perspective. So the user is not bothered about the accuracy, or the user is not bothered about checking all the products. He is only bothered about whether the product which is getting shown to them, whether it is of his interest or not. Okay. And from the vendor's perspective, they try to sell as many as products they can. They try to give a diverse set of products, so that it should not be the case like only very common products are getting recommended to the users, and most of the products are just lying as a waste in the stock. So they have to consider both profit as well as the user satisfaction. Both should be go hand in hand. It should not be one should be scaled up and one should be scaled down. Both should be going hand in hand. Then only we can say that the recommender system serves its purpose. So when we talk about the power of recommender system, I have quoted two two facts. Like one is taken from the Microsoft research report, which says that around 30% of, actually this data is quite old. That is this data I have taken from around 2015 paper. So but now if you see the new article, the percentage of page views by the customers on amazon.com through recommendation has crossed even 40% now. Okay. Similarly, this Neil Hunt, who is the chief product officer of your Netflix, he also in one of the articles said that more than 80% of the movies and more than 80% of the TV series which are watched on Netflix comes through the recommendations. So you can see here how much powerful role this recommender system plays in success of any e-commerce environment. Okay. So coming to the evolution of the recommender system, so in the era of abundance of information on the web, the consumers use many strategies to determine how they can use their free time, what to buy, and whom to date. So in order to give users the recommendations during the interaction with this broad information, the recommendation system automates certain techniques. So this recommender system is a major player in the field of your movies, music, books, photographs, journals, news, and even now the education related also. If you suppose if you open a course or a website, and if you have gone through any course on that, automatically it starts recommending you, automatically it starts emailing you. So how they are performing all this? So these all are in the back end. The recommender system is working. Okay. So usually the conventional recommender system produces recommendations for users through four different filtering techniques. One is your demographic filtering, another is your content based filtering, collaborative filtering, and the hybridized techniques. The, according to the researchers, the hybridized techniques are the revolution for the recommender system, because they are based on the previous base recommender systems with some modifications, so that they can cope up with the problems which are faced by your content based and collaborative based. So we will see in the upcoming slide. In the next slide we have the classification, so we will cover up that. So when we talk about the content based filtering recommender system, the items close to those items which are previously chosen by the users. While if we talk about the demographic uh, characteristics, the demographic characteristics of items includes like the age of the user, gender, location, the attributes of the items. These will be considered to produce the recommendations. And if we talk about, if we relate this recommender systems to the research related, so many recommender systems has been constructed for several domains, such as we have Ringo for the music, we have Belcore video recommender for the movies, and we have even Jester. So if you are working on the recommender system, you might have come across these terms. So talking of, coming back to the diagram which is shown in this very slide, that is, this diagram is showing the evolution of recommender system over the passage of time. It all started with item hierarchy. So the best buy combination. You might be aware of this item hierarchy, like people, means you have bought a printer, you might need an ink. That is, it is trying to frame some associations between the items in which you have showed the interest. It is trying to form some best buy combinations. So this is very base model, so it's quite outdated and nobody uses it nowadays. Coming to the next level, that is the attribute based recommendation. So this attribute based recommendation checks the attributes of the items in which you have showed some interest. Okay, for example, suppose you have watched an action movie starred by Tom Cruise. Okay, so the here the attribute is that the actor is the Tom Cruise. So what the recommender system will do, it will start recommending, and it will start recommending all the movies which are related to Tom Cruise. And suppose the movie which you watched was Mission Impossible series, so it will start recommending you all the action movies which are starred by Tom Cruise. So that will be termed as your attribute based recommendations. Here we are checking for the attributes of the particular item. The next revolution in this evolution came in the mid 2010, around 2010, when the Amazon.com started working on the collaborative filtering. So this collaborative filtering was basically divided into two subparts. That is, your one was based on the user based collaborative filtering, and the second was based on the item based collaborative filtering. So what happens in the user based collaborative filtering is that in the user based collaborative filtering, they try to compare two users, like how much similar they are and what sort of items they have showed interest in. I'll, um, I'll show one thing. Like suppose we have a user A and we have another user B, and suppose this user has liked item I1, then he has liked item I2, and suppose there is another B user who has liked item I1. So you can see here, suppose, and we were having three items in the data set, that is I1, I2, and I3. So, this is just a very small example I am giving. So out of these three items, you can see that the similarity between A and B will be very high. And suppose this A user has rated the item 1 as 4, and he has also rated item 1 as 4. So you can see here the similarity between user A and B will be quite very high. So automatically what the recommender system will do, it will recommend this particular item I2 to the user B. This will get recommended to item user B. So this is how and we have different set of similarity metrics in order to compute the similarity between your users or the items. We will come on to that also in the upcoming slides. The relation between the similarity between the item to item similarity and user to user is that both are going to compute the similarity. The only difference is one is going to consider the users present in the system, and the other is going to consider the items present in the system. And one more key thing to keep in mind while doing the recommender implementing any recommender system is that they try to ignore the impossible correlation. Like over here, if you see in this very diagram, like it has one example is given here. People like you who bought beer also bought diapers. So if you see in terms of the items, the beer and the diapers are having no kind of, it means it's kind of impossible correlation is there, but the recommender system does not care about that. They don't care whether there is any correlation between the items or not. They will recommend it to you if that item is getting, if item is showing some interest by the user, if the user are purchasing beer as well as the diapers together, so automatically they will recommend it to you. They will not see whether there is any kind of correlation between the both the products or not. Okay, coming to the next level, that is the social and internet based, internet graph based. So this is basically covering your social media sites like your Facebook, your LinkedIn. So there we get to know about the people you may know, or the jobs you might be interested in the LinkedIn. So that all works on the graph based approach. So, and the final is the model based, where we used to train some machine learning models, and then for here one word is given, the implicit features. Like basically the recommender system can work on two ideologies. One by considering the implicit data or the explicit data. So the implicit will be considering your clicks, your without passing any external things, while the explicit will be considering your rating data which you are going to provide from your end. Okay, so this is how the recommender system evolved with the passage of time. Coming to the next slide, the classification of the recommender system. So this is a rough taxonomy which I have tried to show over here, that the recommender system can be categorized as your content based, collaborative based, hybrid, and there are some other personalized services. When we talk about personalized, it's the same. We can call the recommender system as recommendation system, personalization system. All are one and the same. So don't get confused if you come across different all these different terms. Okay. So coming to the content based system. So we'll get back to this slide, but I'll show the next slide, which is having the diagram showing the content based systems. So what actually this content based system does is it examines the attributes of the items which has been rated by the user in the past, and it builds the portfolio of the user interest. It uses the keywords to describe the item, and this type of system is based on some reclamation or analysis and the filtering of the information. This particular diagram is showing us the working of this content based filtering, and it is ultimately working on giving us the top and recommendation. So it is checking, if you see on the left hand side, user X profile is there, the name of the user is X, and it is showing what are the attributes of the items on which the user X has shown some interest. Okay, and then this user profiling and learning, what it will do, it will try to find similar similar items which are matching the attributes on which the user has shown interest in the past, and then it will rank in some form, and then it is going to give you the recommendations, if top 10 recommendations. Like suppose if you have a window which is having the capacity of recommending 10 items, then the top 10 recommendations it is going to provide you. So this content based system hangs on two notable ideologies. The one is the attributes of the item, which serve the attributes of these items serves as a supplementary information apart from the rating information. Okay, so this set of information, this set of attributes will act as a supplement for building up the user profile. But keep in note that we will also consider the user ratings, whatever the rating the user has given to that item. For example, if suppose for this very item here we have, and the user has given very low rating, that is in the scale of 1 to 5 he has shown given the rating of only 1. So in that case this item is not at all efficient for the recommender system, right? We will try to pick up only those items on which the user has shown a greater interest, not the will not pick all the items on which the user has shown even the bad interest also. Okay. And the second ideology is that the user portfolio, which comprises of the user interest information, and it basically holds the items for which the user has shown interest in the past. So it ultimately is going to help us in analyzing the user's past behavior. Means how, what kind of item he was interested in the past. Okay. So some of the some advantages of this content based system is that one of the major advantages is that here we are dealing with independent user. The independent user here means that in order to build a personalization system, this CBS does not require the similarity index between the users. The recommendation list can be generated by analyzing the item attributes and the profile of the users. He need not to consider any other users. Okay, so he is self-dependent. The system can generate the recommendations on an individual basis. The next is this content based system will have enough information to avoid the cold start problem. This cold start problem we will discuss when we will be talking about the research problems in depth. For now I'm not covering the cold start, will come up in the upcoming slides. So this content based, at that time I will say how this content based is going to help in solving the cold start problem. So actually, and the third is a transparent behavior we are having over here. So this system is going to make you aware of the attributes of the items on basis of which the recommendations has been made. So, but this CBS is a very base model and it poses a lot of demerits also. That is why it is not being used in the real world scenario. So this content based system will have the problem of it will face insufficient diversity will be there, insufficient novelty will be there, and it might be a high possibility of inaccurate uses of attributes of item selection. Then it is going to face the filter bubble problem, that is the recommendation of similar item which the user has already liked in the past. Suppose, like, if we talk about the content, if the user has already bought a shoe of Adidas, and if we are talking about the content based, so what will be the attribute of the shoes, what is the brand Adidas, what is the size, what is the price, and then on the basis of content based if we are recommending him again the shoes even though he has purchased it, so that does not make any sense, right? So in that case this kind of problem will be termed as a filter bubble problem. Okay, so this content based system stuck in that filter bubble problem. Next is your collaborative system, which can be further categorized into memory based and the model based. So first, what actually this collaborative system is. So this type of system of recommender systems makes a recommendation to the active users by using information about other users and their relation with the item. Like here, if we show here we have set of 6 users, right? And we have, suppose these on the left hand side, these are the movie names A, Z, B, Z, C, Z. Okay, and on scale of 1 to 10 we have given rating 8, 2, 4, 8, 9. Okay, so these are the ratings, and whatever is suppose in DZ here, if you see there is nothing mentioned here, it means like the rating has not been provided by the user F. Okay, so we will consider all the set of users, we will perform some kind of similarity computation between what is the similarity between user A and user B, user B and user C and user D. Likewise, we will compute the similarity between n minus 1. A will, suppose n users are there, then this A will compute, this system will compute the similarity between with this A with respect to all other n minus 1 users. Okay, and on the basis of that we will see which user is most similar to, and accordingly we are going to make the recommendation. So here in this case, if you see, they have computed one example like user A is most similar to user F. Okay, so user A is most similar to user F, and we can see here that user F has shown interest on the movie ID CZ with a rating of 8. So the same movie CZ is recommended to the user A. That is how this collaborative system works. So as I said, this collaborative filtering is further divided into model based and the memory based recommendations. So when we talk about the memory based, this memory based is known as your heuristic based collaborative system. So if you have studied machine learning, you might have come across this term heuristic, right? So this memory based is also known as your heuristic based collaborative filtering. So it makes of the user rating data set to compute the similarity index between the set of users or the set of items, and these are further categorized into user based and item based, whatever we studied discussed so far. This user-based filtering focused on computing the similarity between the users on the basis of their rating behavior, and it has certain limitations such as high computational cost will be there. Then it has certain scalability issues, and in order to overcome the challenges being faced by the user-based model, the Amazon.com introduced this item-based in around 2011 or 12. I am not able to recall the exact year right now. I think it's version 2012 when they introduced this item based recommender system in order to cover up the problems faced by the user base. The cold start user problem actually means the cold start user here refers to that when a new user is coming into the system, when a new user is opening an e-commerce website, how we are going to make recommendations to them in such case. So that will be taken care by the item based collaborative systems, and it has noticeably improved system performance, and it also worked efficiently in case of when we have when we relate it in terms of the scalability. Okay, and then we talk about the model based collaborative system. So it is well known, this model based system is well known for exploiting the group selection of the utility matrix. And the utility matrix contains the ratings which are given to the item by several users present in the population. So the model based system makes use of machine learning and data mining techniques to train the recommender systems. So model based methods exploit the group selection of ratings to predict the ratings, and it can perform offline computation for training, and it is going to achieve better accuracy as compared to your memory based system. For example, we have the association mining model, clustering model, Bayesian model, neural network model, singular value decomposition model, latent dirichlet allocation model, matrix factorization model. So there are different model based systems. Okay, so what can be the possible advantages of this collaborative system? After looking into this, we can say that this system is going to apprehend the change in user behavior, like change in user behavior in the sense like if any new user likes any new item, we can know what is the change in the interest of the user that will be captured by your collaborative system. And it is also going to produce the diverse and serendipitous personalization list, and it also provides a solution of filter bubble problem, the one which we discussed just now. But what is the problem over here? What can be the possible cons of this collaborative system? It can be very much complex and expensive system in case of very high dimensional data set. Just imagine, suppose if we have around 1 million users, and we want to compute the similarity between that 1 million users each and every time they explore something. So you can see over here how much overhead is there in the computation of the similarity. So that was one of the problem being faced by this collaborative system. And most of the data sets in real life scenario are sparse data sets, right? So like when you talk about the Amazon data, if you download or if you explore the Amazon data sets, you will come across that obviously if you talk about yourself also, that you are not going to rate all the items which you explore on the internet. You are not, you ultimately most of the items which are present on the system are going to be unrated. That is, we call it by NA, not available in terms of data set. So in that case, this recommender system will might lead the recommendation system in a wrong direction because we will not have enough data to compute the similarity. So in that case, we might go into the wrong direction, and we might not achieve an efficient system for recommendations. Okay, then next is the hybrid system. So when we talk about the hybrid system, as I said in the introduction, that the hybrid system brought a revolution in the recommender system, and it is said that the hybrid systems are going to be the future of the recommender system. So basically, what hybrid system means is that by the name itself, the term hybrid, you can come to conclusion that it is going to condense the different existing models, such as we talked about the content based, we talked about collaborative based, or any other personalization techniques, or any other models, which when we are going to condense it into a single system, that will be termed as your hybrid system. So this technique came into picture to overcome the bottleneck being faced by the most widely used collaborative systems. Okay, and it can also be referred as a combination of one or more technique. For instance, like a system making use of matrix factorization to reduce the dimension of large data set, and later using the collaborative information filtering to generate the personalization list, can be stated act as a that can be stated to act as a hybrid system. So, like use of genetic algorithm to optimize the performance of the cluster found by users can also be appraised as can also be appraised in order to construct a hybrid system. Okay, so one diagram over here I've shown is that suppose like we have a two user based and item based collaborative system. Suppose we are merging both, we are using both to finally generate the recommended system. In that case, that will also be termed as your hybrid system. Suppose over here on the left hand side, suppose these were the set of items which we received uh, after implementing the user based algorithm, and on the right hand side we obtained the set of items which we obtained after implementing the item based algorithm. Okay, so we will perform some kind of ranking on that. On the we'll perform by we'll merge set of items received, and we'll perform some kind of ranking. This ranking can be based on the accuracy metrics or the rating values predicted. Okay, mostly it's in terms on the ratings value predicted. Okay, so I have not mentioned the rating values over here, so just consider like this: for five set of items highlighted, showing that the user, these are the top ranked items which the user might be interested in. Okay, here in this taxonomy I have also mentioned different hybridization techniques. So before coming to that, so you might by now you might have concluded what can be the possible advantages of this, that it is going to be highly effective in combining the benefits of different recommender systems. It is going to overcome the major drawbacks of the content based and the collaborative based, such as your cold start problems, sparsity problem, gray shift problems. There are different problems which are there in the recommender system. So even if you come across even if you explore the recent researches in the direction of recommender system, you will see most of them are working on the hybrid systems only. Okay, and it is going, this hybrid system will possess an improved performance as compared to the collaborative systems. Okay, but the demerit of this is the cost of implementation is going to be high. Okay, and it is going to possess a high complexity if if we relate it in terms of time complexity as well as the space complexity. The complexity level of this hybrid system is going to be high, and we are going to make use of the explicit information to build a hybrid system, which is very much hard to collect because of some privacy concerns. Okay, these are some of the demerits of this hybrid system. Now coming to the different techniques of this using which the hybrid system can be implemented, we have weighted, cascade, switched, mixed, meta level, feature combination, and feature augmentation. So one line I'll just describe for in one line what actually this weighted means is the decision for this for the hybrid system and weighted approach is taken on the basis of score which is obtained from different recommender system. So the result of each recommender system is combined in a single numerical component to decide the final recommendation list. Okay, that will be termed, some weight values will be associated with all the recommender systems, and finally the list of recommendation will be generated. Next is a cascade. In case of cascade, the recommendation is based on chain of recommendation. That is, one recommendation is fine tuned by other. By what that mean is, like suppose this is one recommender system. It is generating one set of list like I1, I2, I3 to IN. Okay, in case of cascade. So what actually we see here, suppose if we see here only the system is yielding high accuracy, but apart from accuracy we also want the system to yield high diversity. So we can add over here another recommender system, which is suppose based on the graph based approach. Okay, graph based approach, GBA, and then the list D1, D2 to DN. Another list of items is getting, these are the diversified list, which, so ultimately we are fulfilling the accuracy plus diversity by making use of chain of recommendations. Okay, so that will come under your hybrid cascade approach. The third is your switched approach. Now in this case, the switch case, the switched method is capable of choosing one technique from the set of available techniques. Okay, suppose we have a set of recommender systems, set of different techniques. So which technique will perform on which data set well can be chosen by using of switched approach, just like a switch. Okay, either switch will be on or off. So out of set of possible things, we can choose one. Okay, by doing some kind of one hot encoding on the set of recommendation systems. Okay, next is a mixed approach. So this different recommender systems work together in case of your mixed recommender system to give a collaborative decision. Okay, rather than where it is. Okay, rather than using a switched approach or a chain, here all these different recommender system are going to work together in order to give the recommendation, and equal weightage is given to all the recommender system. That will be termed as your mixed approach. Okay, then is a next is a meta level. So the output of one recommender system is used as input of another. So if you relate this cascade and meta level, the difference is that the out in case of meta level, in case of cascade, the output of one recommender system, there was some chain of recommendation. But here, the output of one recommendation system will act as an input to the other. So that will be termed as your meta level. And the final two are feature combination and feature augmentation. So in this case, different knowledge source features are clubbed together to form a single domain. Similarly, for feature augmentation, different knowledge sources is computed to make it compatible to work as an input for many different recommendations algorithms. Okay, and finally, if we talk about the different personalization systems, we have demography based, knowledge based, community based, and as I said, this demography based approach was one of the very basic or one of the base recommendation models in the earlier days. So this demographic recommender system utilizes the user demographic information uh, such as the demographic data of the users, gender, age, location, qualification, and it assumes that all users belong to a certain demographic group. Okay, and have similar preferences. If they belong to a similar demographic group, they all prefer similar preferences. So this type of recommender system is very unsuitable for users in real life applications, because it's very hard to collect the demographic data of the users, but it can be used as one of the methods to solve the cold start user problem as well as the cold start items problem, when we don't have any information regarding what the user might be interested in. In that case, we can use the demographic data of the user and we can proceed with it until unless the recommender system becomes warm enough to make the recommendations to the users. Okay, then next is your knowledge based. This type of recommender system makes use of the knowledge about the users and the products for generating the recommendations, focusing on the user's interest on any particular set of products and checking whether the recommended products meets the user requirements or not. So since this system analyzes the relationship between the item that needs to be recommended and the item that is actually being recommended. So these systems are can be further classified into your case based systems and the constraint based systems. This knowledge based systems can be further categorized into your two further categories are there of the knowledge. One is your, sorry, one is your case based and one is your constraint based. So if we talk about the case based, what actually is one is your case based, second is your constraint based. So if we talk about the case based, it is going to exploit the problem solving methodology that that is going to that tries to solve the any newly introduced problem by redeeming similar problem that has been encountered in the past or that has been solved in the past, and it is going to reiterate the solution for the new problem. Okay, and next is your constraint based. So this constraint based systems it going is going are going to specify the constraint on the attributes of the item. Certain rules are defined that matches the user requirements with that of item attributes. So this type of system requires the user requirement definition, item attributes, then constraints explicitly. So whenever we face this over constraint problem, we follow certain steps. Okay, we in this constraint based, this type of recommender system might face the over constraint problem. Okay, so it might get stuck in the problem of your over constraint. So what we can do in that case, this when in order to solve this over constraint problem, we can reorganize the model by revising the constraints and preferences, or we can try to find a solution which is going to satisfy the subset of the constraints. Okay, so this was about the knowledge based, and the last is your community based. The community based, as the word itself says, that it is focusing the community. Okay, so the community which shares some common interest. Okay, it uses the user item interaction inside a community and recommends item after aggregating the decision obtained from the community. So it overcomes the sparsity and the cold start problem associated with the new users. So this is all about your recommender system approaches, evaluation of recommender systems. What are the different recommender system algorithms which are available to us, and this is the complete taxonomy of that. Okay, so this all we covered. Now we can talk about the data types which are used in the recommender system. Let me maximize it. Okay, so in general, for the purpose of creating the customer's portfolio, it is very much important to know what the customers are browsing on the web. So different websites consider different types of input data from the customer for calculating the recommendation. So this type of data can be classified into your five types, namely your behavior pattern data, socio-economic data, then rating data, proceedings data, informative data. So when we talk about the behavior pattern data, so the behavior pattern data includes the statistical data. Okay, let me once again open this tab. So when we talk about the behavior data, the first one, that is your behavior data. So in the what happens in behavior data is it is going to include the statistical data about the characteristics of a population, such as we can consider the customer identity. Customer identity can be there, it's sex, then what is the age, the occupation, the contact number, then the date of birth, hobbies, work experience, income of the people within the population. So these all kind of data will be considered as your behavior pattern data. Next is your socio-economic data. In case of your socio-economic data, this type of data is used to identify the common communication patterns between the objects, and we are going to realize the patterns. So it includes your click times. Okay, how many times you have clicked, how much time you have spent on a particular page. Okay, then the duration of browsing. The duration of browsing will be covered by your socio-economic data. Then we have the user operations on web content, such as the downloading. We can consider the downloading, what he has downloaded, the scrolling, and several other homogeneous activities that will all be come under the socio-economic data. The third is your rating data. As you all know, rating data though is quite obvious, the rating informative data. Okay, so we'll not talk about this. Coming to this rating data, also one more thing, it can be discrete as well as continuous. So continuous rating, it can be, or okay, let me write, it can be discrete ratings, or please avoid my, means ignore my bad handwriting. So if you have any doubt, you can stop me in between. Discrete and discrete rating or the continuous rating. Okay, and when we talk about it also comprises of the inherent remarks. Inherent remarks means inherent remarks can comprise of whether the item is good, bad, worse, very good. So these are the inherent remarks which will also be considered in your rating data. The fourth is your proceedings data. So in proceeding data, it describes an event and always has a time dimension. Okay, it includes this proceeding data. It is going to include your purchasing details, the item purchasing details, such as you have what is the purchase date, what is the purchase date of the item, what is the purchase quantity, okay, what is the price, what is the cost of the item which you have purchased, why you purchased it, how much discount percentage was given on that very particular item. So this all will be covered under your proceedings data. Okay, and the last and the foremost is the production informative data, PID. Okay, this production information data, this type of data is stored perpetually for regulating your business processes. So this the information such as your content descriptions for the web and movie attributes for movies, which are used by the business professionals to take proper decisions which well suits the organization's economic growth. So the production data must be documented efficiently in order to ensure its value to the organization. So this production information data, if we relate it with the terms of your movie length data set or your just a data set, there will have some pre-stored data, like we know about the movie genres prior. Okay, we are not waiting for any action from the user end. We already know the attributes of the movies. These are all the pre-stored in the system for regulating the business processes. Okay, so this all will come under your production informative data. Okay, so this was the different data sets which were data types, not data sets, data types which we can use for building any recommender systems. Then coming to the similarity measures used by the recommender system. So the performance of most of the recommender system depends solely on the similarity measures, and the precise similarity calculation decides the accuracy of the model. So each similarity has some pros and cons associated with it, and out of all the different similarity measures in the recommender system, the Pearson correlation coefficient is one of the most widely used similarity measure for the recommender systems. So we can categorize this set of similarity systems into the two, that is distance based similarity and correlation based similarity. So coming to the distance based similarity, we have the Euclidean distance, which you all already know. And if we give the mathematical equation for if we give the mathematical equation for this, suppose we have z1 and z2 as two set of points or objects, then the distance between z1 and z2, or the Euclidean distance between z1 and z2, can be given by the under root of I is equal to 1 to n z1 minus z2 whole square. Okay, this will give you the Euclidean distance between the two set of points. The closer the distance, the more similarity between the users or the items is there. Okay, the more similarity between the objects is there. So it is going to measure the distance between 2 points. Okay, so here the z1 and z2 are 2 points, or the objects in the Euclidean space whose similarity we want to calculate. So this z1, if we term it in the terms of user, this z1 and z2 can comprise of certain dimensions like z11, z12, z1, so up to z1, and similarly this also can have z21, z22. So based on your data set which you have picked, or based on the system which you are working on, the dimension of these points will lie on. Okay, and this is all representing the Cartesian coordinate format, and this n is representing over here. This n is representing the dimensions of the Euclidean space which we are talking about in the system. Okay, this is your Euclidean distance. Then if we talk about the Manhattan distance, it is also similar to that only, but only the difference in that case of Manhattan distance is that we compute the distance by considering this distance between z1 and z2 is equal to summation of This is summation of I is equal to 1 to n. We take the modulus z1 minus z2. So in what case we use Manhattan distance? The distance measure, in this case, the distance measure computes the distance on the grid lines. Okay, it is calculated by summing up the horizontal and the vertical component of any set of points. These are the two set of points, and we are considering the horizontal and vertical components. Okay, and the dimensions can again be defined by same z1 to zn and z2 to z2n. Okay, and the third is your Minkowski distance. So this Minkowski distance is going to display a generalized representation of both your Euclidean and your Manhattan distance. So we can write it as, and one more thing, if we compute distance between z1 comma z2 or z2 comma z1, both will result in the same. Okay. So the equation for this is I equal to 1 to n z1 minus z2 p to the power of 1 by p. So this p is representing the dimensions. Okay, so this was your distance based similarity. But if you go through different research papers, most of them will avoid using distance based similarities, because there in that case we have to capture the behavior also. Okay, so we try to go for the correlation based similarities. So if we talk about the first most famous correlation based similarity, that is Pearson correlation coefficient, PCC. Okay, so this PCC is in this similarity measure, the similarity is computed between the objects or the points on basis of common items or the ratings. The similarity value is going to lie between the -1 to your +1. The -1 is representing your negative correlations. Okay, and the +1 is representing your total positive correlation. Okay, and in between, if you get a 0, this 0 is representing your no correlation. There is no correlation between the set of users. Okay, the more the value is near to +1, the more similarity between the users are there. So they are highly correlated. So the equation for this can be written over here as PCC between z1 comma z2. This when doing the hands-on, we will use this Pearson correlation coefficient to compute the similarity between the users. So if you can write it down somewhere, so it will be better, so that you can relate how we code the same Pearson correlation coefficient while we do the hands-on. Okay, so in the numerator we have I is equal to 1 to n z1i minus z1 dash. This z1, suppose this z1 is the user, this I is representing the item. Okay, so the rating given by z1 user to item I, and this z1 dash is representing the average rating given by user z1. Okay, then z2i, we are trying to compute the similarity between the user z1 and user z2, and this n is representing the total commonly rated items. Okay, so this I is representing a first item, so how much rating the user 1 has given to item I. This z1 dash is representing the average rating given by user z, and z2 minus z2 dash, okay, divided by under root of I is equal to 1 to n z1i minus z1 dash whole square under root of I is equal to 1 to n z2i minus z2 dash whole square. Okay, so this is going to not only capture the similarity between the users, but here if you see, here we are using the average similarity, means average rating given by the user also. So this is somehow I is going to normalize also. Okay, so this is that is why this PCC is very much efficiently being used in the terms of recommender system. Next is your cosine similarity. The cosine similarity can be already, I think you might be aware of this cosine similarity. We try to form on the angular basis, like how much similarity is between, based on the theta value, how much similarity is between the two users A and B, right? So similar kind of thing we try to do over here. We try to compute the cosine similarity. Cos theta is equal to I is equal to, sorry, cos theta is equal to I is equal to 1 to n, okay, z1I dot z2I divided by under root of I is equal to 1 to n z1I whole square under root of, okay, these two under roots are separate and they have a multiplication in between, and under root of I is equal to 1 to n z2I whole square. So this is going to give you the cosine similarity. Similarly, but what happens, the problem is there in that in this cosine similarity is that if the rating behavior of two users is not matching, in that case this cosine similarity is not going to work efficiently. Okay, for that we use the adjusted cosine similarity in order to solve that very particular problem. So in this case, adjusted cosine similarity, suppose we have a set of user u who have commonly rated the item which belongs to you, who have commonly rated I1 and I2. So RU I1 minus RU dash, it is somewhat similar to the Pearson coefficient, PCC, but not same. Okay, so don't get confused with the terms. And please cross check this adjusted cosine similarity also. As far as I know, I'm writing the correct. So this complete will be in the under root RU I1 minus RU dash whole square. And once again, the same now, rather than I1, we will do for the I2 over here. So this will compute our the adjusted cosine similarity. And finally, the Jaccard similarity. Even though we don't use this Jaccard similarity a lot, we have Tanimoto coefficient also. But we those things, even though they are they can be used to find the similarity, but they are not at all efficient in order to compute the similarity in the among the users or items. So these are some of the famous. So in the Jaccard also we have, you might be knowing z1 intersection z2 by z1, sorry, this will also be modulus z1 union z2, which can also be written as z1 intersection z2 divided by modulus of z1 plus modulus of z2 plus, oh sorry, not plus, minus modulus of z1 intersection z2. So this can be also used to compute the similarity. This is known as the Jaccard similarity, and it is an index value used for calculating the similarity and diversity of set of objects. So it is divided, it is defined as a division of the intersection over the union. Okay, intersection over the union. And here the similarity ranges from 0 to +1, where this 0 represents the low similarity and the +1 represents high similarity. Okay, this was all about your correlation based similarity. Now if we talk about the evaluation matrix, so it depends whether you are working on a regression based problem, or you are working on a classification based. So suppose if you are predicting the ratings, in that case you can work on mean absolute error, root mean square error. So these metrics are widely used. So the performance of the recommender system is evaluated under certain scenarios and in order to decide its efficiency. If we talk about the mean absolute error, this MAE can be defined as the deviation of the predicted rating from the actual rating. That can also be written as I is equal to 1 to n AI minus PI, or you can also write PI minus AI. Since we have a modulus sign, so it does not make any effect. Okay, by n. So this is going to give your mean absolute error. This AI is none other than your actual rating of the item I, and this PI is giving your predicted rating. Suppose we have made a recommender system model, and we are predicting we are predicting the rating for item X, and we suppose we predicted the rating as 4, but the actual rating for that item X was 3. So how much deviation is there? That will can be calculated by your mean absolute error. Okay, the next is your root mean square error. So in case of root mean square error, this is another metric which has which is similar to mean absolute error with a square root on it, AI minus PI. Actually it should be bracket, not the modulus, whole square by n. This complete will be in under root. Okay, Uh, this complete thing is in one single under root. Okay, this is known as your root mean square array. Similarly, if we talk about our precision, recall, F1 score, and accuracy metric, so before talking about that, better to discuss about the confusion matrix. So you might be aware of this confusion matrix. Like suppose this is representing our predicted class, okay, and this is representing our actual class. Okay, so suppose this 1 is representing the positive and this 0 is representing the negative. 1 is representing positive, 0 is representing negative. So this will be termed as your true positive. This will be represented as your 0, 1. False positive. This is predicted. Okay, yeah. So this will be represented as your false negative and this will be represented as your true negative. Okay. Okay, so this is termed as a confusion matrix. Okay, and one more thing, this false positive can also be represented as your type 1 error, and this false negative can be represented as your type 2 error. If you talk, because ultimately you are going to build some machine learning model for this recommender system, so you should be aware of this confusion matrix, how to calculate that. And if we talk about some more terminologies in this, let me consider. If we talk about the precision, as I given in the slide, this precision we can calculate by true positive by true positive plus false positive. It is also termed as a true positive rate. Okay, this precision can also be considered as a true positive rate. Next, suppose we try to compute the negative predictive value. Negative predictive value that can be computed by considering true negative by true negative plus false negative. Okay, the third and the famous is a recall. The recall can also be termed as your sensitivity. Yeah, recall we can consider it as sensitivity. So how we can compute the sensitivity? By writing TP by TP plus Fn. That will compute your sensitivity. Then we talk about the one more specificity. Yeah, we have a specificity. In order to compute the specificity, we can write Tn by Tn plus Fp. Okay, this will compute the specificity. Now here we have in the slide one more term, accuracy. So by looking at this confusion matrix, you can compute the accuracy by total positive means true positive plus true negative divided by total prediction, that is true positive plus true negative plus false positive plus false negative. So this is going to give you the accuracy. Okay. Similarly, if you talk about the F1 score, that is going to be P into R by P plus R. That P is none other than your precision, and then R is the none other than your recall. So here, this all you can use to compute the evaluation, to evaluate your metrics in terms of your classification problem in your recommender system. Okay. Moving on to the next slide, we will talk about the research problems over now. So if you have decided to work on the recommender system, you should focus on this very particular slide. Okay. So first, let's not start with the large volume. Let's start with the long tail. Okay. Suppose this is representing your items. Okay. This is representing your frequency. So basically, this is a rating predict graph which is constructed over the item and the frequency. Frequency means like how many users have shown interest in that very item. So if you see over here, first let me define what actually a long tail is, then we'll come back to this very particular graph. Okay, the long tail, like if we talk about the today's online stores, they are very much in the booming sector, right? And we can get almost any items at a single click of a mouse. So however, like if we talk about the old days, in the case of your brick and mortar era, there was some limited physical space to store the goods. So hence the owners only used to display the items which are most popular. So this means that a lot of products were not even displayed, right, even though they had a great quality like books or CDs. So in short, the shopkeepers had to filter the contents. However, the online shopping industry changed this scenario. Since there was unlimited space, the need to filter, pre-filter was gone. So on the contrary, this gave us a rise to the phenomena which came to be known as your long tail effect. So this kind of problem is very much common in your e-commerce systems, where most of the rated uh, where most of the rated items are condensed in a small fraction of popular most items. It is the utmost job of a recommender system to consider even the less popular items which are having very few ratings. So this problem can be leveraged by using the content based systems. Okay, and to find the similarity between the new item and the most popular item, which can be further clustered and can be assigned with some aggregate ratings. So over here, if you see, this left hand side can be termed as your head, because you can see here they are possessing a- they are possessing high frequency, highly frequency, and these are the set of unpopular items. So this can be also termed as the tail, the long tail. You can see here the large set of items are lying in the long tail. So we are not able to recommend this very set of items. One very simple example I will give you so that you can relate it with the real life scenario. When you open a Flipkart, you will see most of the time they will recommend you if you go to the mobile phone, most of the time they will recommend you Xiaomi phones, or the iPhone 12 if you go through the Amazon. So these are the very much popular nowadays, so they are recommending that. But if you talk about other similar phones like Xiaomi, this is also available in that website, but why they are not recommending this very particular phone to you, even though it the price range will be this for this also will be around 15 to 20K suppose, but still they are not recommending this. Why is it so? Because this lies in the unpopular zone. Okay, so how to build a recommender system that can cover both your head items as well as tail items, that is termed as your long tail problem. Okay, then we talk about the sparse data. If we talk about, as I said, in the terms of recommended e-commerce environment, most of the rating data are highly sparse. Okay, so it is in almost all the top-notch websites like your Netflix, your YouTube. Only few users give the ratings to few set of items. Thus, it is going to leave most of the data sets as sparse. Okay, similarity computation in such scenario is a very much tough job for the recommender systems. Okay, so that also can be one of the research problem. Next, over ramp up problem. If we talk about the ramp up problem, this problem is basically an extended version of the sparsity problem. The recommended system fails in generating the personalization list unless the system has enough amount of rating information. So the researchers suggest to make use of other explicit information such as the demographic data, location, age, feedback form in case for solving your ramp up problem. One is the over specification if we talk about. So this problem arises when the system has information about the systems in which the users are interested and thus never suggest any item other than the category of items. So this type of problem leads to the lack of diversity. Okay. Then is your user drift of interest. Okay, changing interest of the users or changing user behavior. So that interest and taste of users drift over the time as the new trends appear and new items become available. So how we are going to capture that, that is also one of the problem. And if you want to go on a research for this recommender system, this shared profile you can pick, like this is still a novel means problem. This is still an open area of research and very limited, or we can say very small amount of work has been done in this domain. Like when suppose two users are sharing the same profile, how you are going to make recommendation in that case? Suppose, like if we talk about a friend, a boy and his girlfriend, both are using the same e-commerce website, or a mother and a daughter, or a father and his son are using the same profile. So in that case, the choice or the selection of both or the interest of both the person will vary. how you are going to make the recommender system efficient in that case? Because if you recommend a toy to a 70 years old grandfather, and if you recommend groceries to a 6-year-old kid, the purpose of the recommender system will fail in that case. So how you are going to deal with that? That can be one of the problem. The next is the gray shift problem, which can be further classified as your white user and the gray user. So the gray shift represents the users whose correlation value with the other users is very low. Okay, so their interest category does not match with any other user present in the system. So how you are going to deal with that? This, in that we have the white user, the set of users who possess very high core user correlation value, and the gray users, the set of users who possess low correlation value. Okay, so coming to the next, so these are the different research problems. There are several other research problems, but I have just picked some of them, so you can explore more about those things. If we talk about the applications, these are some of the snippets which I have taken from different applications in order to show, like here if you can see this Amazon uses the data from its million of customers to identify which items are usually bought together and makes recommendations based on that. Okay. The next is LinkedIn, so that it is going to show you the top job picks for you. The next is Netflix. So when we rate a movie or set up our preference on Netflix, it uses this data and similar data from hundred of other subscribers to recommend movies and shows. These ratings and actions are then used by the Netflix to make the recommendations. Similarly, Facebook, people you may know. So when we talk about the goal of recommender system, it can be categorized into four major scales. That is relevance, novelty, serendipity, and diversity. Okay. So the relevance means the recommended items will only make sense if they are relevant to the user. Users are more likely to buy or consume items they might find interesting. Similarly, if we talk about the novelty along with the relevance, the novelty is another very much vital factor. So the recommended items will make more sense if the items are some things that the user has not seen or consumed before. Okay. Then we talk about the serendipity. There is a quite confusion between novelty and serendipity. Sometimes recommending items which are somewhat unexpected can also boost the sales. Serendipity is, however, different from the novelty. For example, if a new Indian restaurant opens in a neighborhood, then the recommendation of that restaurant to a user who normally eats Indian food is novel but not serendipitous. Okay. So on the other hand, when the same user is recommended Italian food and it is unknown to the user, and that such food might appeal to the user, so then that recommendation will be termed as your serendipitous. Okay. And finally is your diversity, which also increasing the diversity in recommendation is equally important. Simply in recommending the items which are similar to each other is not of much use, but one thing you have to keep in mind is that if you increase the diversity a lot, the accuracy is going to compromise. The diversity and the accuracy are inversely proportional to each other, so we have to take care of that. We have to make a proper balance in that case, such that we are satisfying the accuracy as well as the diversity at the same time. Okay. So let us see one small implementation of the recommender system using Python. 15 minutes still there, so I hope I'll be able to show the recommendation implementation. So before that, let me show you what constraints and what are the inputs which I have taken. So this is the data set. I am working on the Movilance data set, which comprise of 943 users, 1682 items, and the total ratings which are available in the system is 1 lakh, and the sparsity is around 93.70. So here if you see, when we are talking about the 100k, these are the standard data sets, okay, from the group lens research group. Okay. So if you see over here, the sparsity percentage here, if you see 99.47, this is the sparsity percentage. So how accurately you can train your model, how accurately you can build your model, that will be a challenging task, because most of the data is sparse in that case. So when you are building or working on recommender system, you have to deal with those things also. Okay. So this is just a visualization of data visualization, or you can say EDA. Okay. EDA for your movie lens 100k data set, just exploring what are the different these are the different occupations of the users, these are the different genres, which are available for the movies. This is a mean movie rating. We have shown the ratings per movie, ratings per user, mean user rating. So these are the different information which I have showed over here regarding the movie lens 100K data set. Okay, so what I have done in the implementation is that we have tried to find item, what are the similar users who have rated that item, and for computing the similarity, means for computing the ratings, we have used one equation. Okay, I'll come back to that equation. First, let us see the implementation, otherwise the whole purpose will fail. Okay, we'll come back to the feature direction later. Let me show you small implementation for that. So let me start a new file and then okay, is the screen visible to all the code which I am writing?
Yes, sir. Visible, sir.
Yes, sir.
Okay,
Yes, sir. It's visible for us.
okay. So first and the foremost thing which I have to do is to import the packages. Like we will need first. Let us import the math for doing the mathematical computations. Math for using the mathematical functions, we'll use the math. Then we will need sys. We can need for this. This will provide the information about the constant functions and the methods of your Python interpreters. Then we will use the pandas, and we'll use model selection for doing the cross validation and the train test split. So now we need to use this sklearn dot model underscore sklearn dot model underscore selection import cross underscore validate as, suppose we'll let it as CV. Then we write in from sklearn dot model underscore selection import train test split. Okay, I think it's
Excuse me, sir. Can you please zoom the screen or increase the font size?
okay, sure.
Thank you, sir.
Is it fine now?
Thank you, sir.
Okay. So after this, we will need a file. So I have already. Wait, let me, before coming to this u.data, let me show you what actually the file I'm working on with. So this readme, this is the summary of the movie lens dataset on which I'm working on. So we have picked the u.data. So where is it? Yeah, here. So this is the information which we are going to pick. So this u.data is comprising of 1 lakh ratings by the 943 users, and the total number of items which are present in the system is 1682. Okay, so this is what we are importing, and each user has rated at least 20 movies. So this data set you can download from the group lens, movie lens 100K. So we need to upload the data set before using that u.data. Okay, we'll proceed. Now let us perform the loading and splitting. Let me write a message. Loading and splitting of the data set. Okay. Now, there, if you remember in this slide, I said that we are considering the set of users, similar users or set of neighbors. So let us see here, k nearest neighbor. So here we will define the k value over here. How many neighbors you can consider? So you can check for different k values, different neighbor values, what is the optimal result coming. So let us start with the value 20. Okay, then we will check for different k values, what is the optimal result we are coming up with. Let us define a header. So there we were having user ID, then we are having movie ID, user ID, movie ID, ratings and timestamp. And let us import the data set. That is dash E. Now next we need to perform the train test split. Suppose we want to do the train test split in the ratio of 80 to 80 20 or 70 30. Okay, so here we can do train test split, train data and test data we have named them, and cv dot train test split should come. Why it's not coming? Okay, train test split. The name of the data is data set test underscore size is equal to 0.20. Okay, and we will create two data set. One is your user data set for considering the similar users, and the item data set. Let's I data set, let's name it, for considering the similar items. Okay, then we will explore, we will iterate the loop train underscore data dot iter tuples of row 3. Okay, and next let's consider the item data set. Let's fill the item data set with set default of row 2 and underscore data set row 2 dot set default row 1. We test whether loading printing is okay. Some problem is there. It should be read underscore CSV, not read dot CSV. What is the error now? Function object has no attribute train test split. Direct Multiple indices must be integers or slices, not tuple. Oh, I missed here the bracket. Oh, okay, now it worked. The next, first computing the similarity similarity for the users. So we need to define the Pearson correlation. As I said, define Pearson underscore correlation between user 1 comma user 2. Okay, so initially we kept the result is equal to 0.0 user 1 underscore data is equal to u underscore data set. We will take suppose first user, and similarly we can just copy it for user 2 underscore data is equal to u underscore data is equal to data. Then average user 1 underscore data. Okay, and next once again like copy and then paste for another ry average user 2 underscore data. Here we are just computing the Pearson correlation, nothing else. So for movie in user 1 underscore data, if the movie is in user 2 also, means both have rated the data, then in that case we have to use this as we have to add that in sxy dot append. We can use the append to movie, and upper is equal to 0.0. This upper and lower just representing that numerator and denominator. Lower we were having two terms, so let us take lower 1 and lower 2. If you remember this, that Pearson correlation coefficient, from there I am relating them for item in sxy rx is equal to user 1 underscore of item. Okay, rx is equal to user 1 underscore. Then simply just copy, paste. Is equal to upper plus rx underscore x minus x underscore average into ry minus ry underscore average. Okay, and then lower 1, for lower 1 computation we can take lower 1 plus power excuse me, up to what time is I can present?
मला फॉर्मॅट आपण
Hello.
પણ ઓછે મારે પણ કેવું આ તો ખાવાનું બધા કશું ના
Okay, wait, I'll show the code actually. It's similar code. This code is different, but I'll show one. Okay, so let me upload the data set once again. Okay, so this was the list of packages we need. We performed loading and splitting. Then this is for computing of similarity for the users. So the whatever the similarity we learned during the session in the PPT, we saw the Pearson correlation coefficient. The same we are trying to do over here. This is representing the numerator part, and this is the denominator part. So if you see here, and this is just the square. This is the same mathematical equation we have converted in the term of code for computing the similarity for the users. Same we did for similarity for items. Okay, and then we try to find the average rating of all the user data. We have computed the average rating in the training set only. But then we try to form the similar neighbors of the user for any given user, or who are the k nearest neighbors. Then for different k nearest items for the similar items. Okay, and finally the rating prediction is done by this very set of codes. Because of the time boundation, I could not explain the line by line. And finally then we tested our model on the test data. Okay, so if you run here, so these are it is representing the users, so it is computing the similarity and prediction for each user 43, 47 total. If you remember, since I showed you the data set, how many users were present there? 943. So it will go up to there. Okay, and then it will display the mean absolute error and the root mean square error, which we have computed over here in this very set of code for evaluating the performance of our recommendation model. Let it complete, then you will get the final result for the recommendation. Actually, you can work on many deep learning recommendation models also. We have different autoencoders, RNN, CNN. So those deep learning models also you can relate with your recommendation systems. Many recent works are going on related to that. If you go through that, and if you have any problem or difficulty, you can contact me or through my mail ID or my contact number, which will be available to the members. Let it complete, just 300 more. So meanwhile, I can show you one link actually. Meanwhile, the execution is continuing. Let me show you one link. So basically, this link is showing you the content-based system. Okay, so you will get an idea. Right now, let it open once. They have developed a content-based system, and they have designed a beautiful front end and the back end for the working of content-based filtering system. They have uploaded on Heroku. Okay, yeah, it opened. So see, this is actually a movie recommender system. Suppose if you like Avenger movie, right? Avenger or Captain America, or suppose Avenger Age of Ultron. So based on the contents, it will do some content-based filtering, and it will show the set of items you might be interested in. Let it open. Okay, so here is the Avenger movie. So these are the top cast. These are the starred people who have starred in that very movies. So these are the sentiments or the ratings which are given. So you can see the recommended movies. So they have started recommending us the Avengers, Captain America, Civil War, Iron Man 2. So all superhero movies they have started recommending. Even the previous was Endgame, Infinity War, Iron Man. Okay. Similarly, if you try for suppose Inception. Okay, I think it has completed. Okay, so see over here, like we obtained an accuracy of 0.75 to 0.967. Okay, so this is how you can build a similar recommender system models, and you can work on it. Okay, so see, we searched for Inception. These were the actors who starred in that. So similar movies you already started getting: The Dark Knight Rises, Fury Road. Okay, so this particular app front end is completely designed using your Python only. Means the backend working is Python. I have a certain GitHub code for it also. If you want, I can share that. So this is the working of content-based filtering. I hope I gave an overall idea of the recommender system performance. Some future directions is like, if you want to work on the recommender system, you prefer for the continuous streamline information, not the fixed data sets. Don't pick the fixed data set. Try to work on the streaming data, okay, which continuously is going to change, or which poses some dynamic behavior. Use some clustering or fuzzy approaches in order to build the model, in order to give the flexibility to the users uh, to lie in more than one clusters. Okay, use different deep learning approaches. So these are the different future directions. Okay, so I'll end up my session over here. So if there is any question, I'll be happy to take it.
Sir, thank you for your interactive session, sir. Really, it
sir.
was useful. Thank you so much, sir.
Thank you, sir.
Participants are requested to fill the attendance form posted in chat box.
Sir, shall I disconnect now?
Yes, sir. Yes, sir. Thank you, sir.
Thank you.